Hello, in this video I'm going to talk about question number 10 of homework 8 of probability and stochastic processes course. So let's first go to question number 10. Show that if the normal process is wide sense stationary, then it is strict sense stationary. So to solve this problem, we should first look at the definition of a stationary in a strict sense. So we say a stochastic process is a stationary in a strict sense if its statistics is not affected by a shift on the time axis. So this means that two processes, xt and xt plus epsilon, have the same statistics for any epsilon. Now, after, let me correct this to single page. Okay. After reading this definition, we can write the problem. We can write the problem in mathematics and we can write the formula. So f of x is SSS if f of x for x1, x2 till xn and for t1, t2 till tn is equal to f of x for x1 to xn and t1 plus epsilon, t2 plus epsilon till tn plus epsilon. If we can prove this, then we can make sure that f of x is SSS. So let's write down the formula for a joint normal distribution. F of x for x1 till xn and t1 till tn is equal to this formula. And the t is in the C matrix, which we have the inverse of this matrix in our formula. So let's look at this part because t1 to tn is in this part of the formula. Okay, so the matrix C, which is for the variance, is equal to the expected value for x minus eta times x minus eta transpose. And then we can write this formula in terms of t1 to tn. So we can write it like a vector that in the first row it has x of t1 minus expected value of x of t1, which is the eta for with respect to t1, until the x of tn minus expected value of x of tn. Then we should multiply this vector, this matrix, with another matrix, which is the transpose of this matrix. And then after doing this multiplication, we can write it down like this. So in the first row, we have the r of t1 and t1 minus eta 2 till r of t1 to tn minus eta 2. And like this, we have for all the rows. And then we will write it so we will do the minus. So here we have t1 minus t1, which is 0. And for example, here we have t1 minus tn. And we can write it down. And so we can see, for example, in the diagonal part of the matrix is all our zeros minus eta to the power of 2. So this is equal to C of T1 minus T2 and T1 minus T3, all of them till T1 minus Tn. Again, we can write it for T2. So T2 minus T1, T2 minus T3, and we will have this till Tn minus 1 minus Tn. So we can write it like this. So T of Ti minus Tj for all I and j that is not equal to, I and j should not be equal to each other. Okay, so we can again write the joint distribution of x1 till xn, and we can see that because we did the calculations, we know that this is equal to f of x for x1 and x2 and xn for t of I minus tj for I and j from 1 to n. Just I and j should not be equal to each other. And again, let's get back to the term that we wanted to prove. So f of x for x1 and xn till xn, and for ti that has had a shift of size epsilon, and then we can write this down as the f of x from x1 till xn and ti plus epsilon. Ti plus epsilon minus tj plus epsilon for all I and j. And then we can see here that the epsilons are removed, and we have ti minus tj, and we get to the joint distribution that we had before the time shift. So we can then see that x of t is SSS, which means stationary in a strict sense. Thanks for listening to me.